In 1928, a young British physicist named Paul Dirac was staring at equations that refused to behave. He was trying to merge Einstein's theory of relativity with the strange new world of quantum mechanics, and the mathematics kept producing answers that seemed impossible. For every electron the equations predicted, they also demanded the existence of something else, something with the same mass but opposite charge, something that, according to everything scientists knew about the universe, could not exist. Dirac could have dismissed these mathematical ghosts as errors. He could have assumed his equations were wrong. Instead, he made one of the most audacious predictions in the history of science. He declared that his mathematics was revealing a hidden truth about reality itself. These mysterious opposites weren't mistakes. They were real particles waiting to be discovered in a mirror universe of antimatter that existed alongside our own. 4 years later, cosmic ray detectors captured the first antimatter particle exactly as Dirac's equations had predicted, but that was just the beginning. The same mathematical framework that revealed antimatter also hinted at something far more extraordinary. Hidden within Dirac's quantum equation were mathematical structures that seemed to describe not just our reality, but multiple realities, parallel worlds, alternative universes, dimensions of existence that our instruments couldn't detect, but our mathematics insisted must be there. Tonight, we're going to explore one of the most mind-bending questions in modern physics. Did Paul Dirac's equations accidentally stumble upon mathematical proof that other realities exist? And if the mathematics of quantum mechanics can predict invisible universes, what does that tell us about the nature of reality itself? Before we dive into the deep end of parallel dimensions, hit that like button and subscribe, because we're about to journey through mathematical landscapes that challenge everything you think you know about existence. The story we're about to tell reveals how pure mathematics became humanity's most powerful tool for discovering hidden aspects of reality that our senses could never detect. Now, prepare yourselves, we begin. Here's what makes this story absolutely fascinating. Dirac wasn't trying to discover parallel universes. He was simply trying to solve a mathematical problem. But the solutions his equations produced were so strange, so unexpected, that they forced physicists to completely reimagine what reality might actually be. Let me take you back to 1928. Albert Einstein had already revolutionized physics with his theories of relativity, showing that space and time were connected and that massive objects could warp the fabric of space-time itself. Meanwhile, quantum mechanics was revealing that particles at the smallest scales behaved in ways that defied common sense. Electrons could exist in multiple places simultaneously. Particles could tunnel through barriers that should have been impossible to cross. The quantum world operated according to rules that seemed to contradict everything humans had learned about how reality works. Paul Dirac faced a seemingly impossible challenge. Einstein's equations worked beautifully for describing large objects moving at high speeds. Quantum mechanics worked perfectly for describing tiny particles moving slowly. But what happened when tiny particles moved at speeds approaching the speed of light? The mathematical frameworks didn't fit together. It was like trying to solve a puzzle where half the pieces came from one box and half from another, and they weren't designed to connect. Dirac was obsessed with mathematical elegance. He believed that the laws of physics should be expressible in equations of breathtaking beauty and simplicity, so he set out to create a single equation that could describe electrons moving at any speed, from nearly stationary to nearly the speed of light. What he discovered changed everything. The equation Dirac derived was unlike anything physicists had seen before. Instead of producing simple solutions for the behavior of electrons, it generated solutions that seemed to describe two different types of particles. The first type matched electrons perfectly. The second type had the same mass as electrons but carried positive charge instead of negative charge. According to the mathematics, these mysterious positive electrons should exist in equal numbers to regular electrons throughout the universe. But there was a problem. No one had ever observed a positively charged electron. The periodic table contained no such particles. Every electron ever detected carried negative charge. Dirac's equation seemed to be predicting the existence of particles that simply weren't there. Most scientists would have concluded that the equation was flawed, but Dirac made a different choice. He trusted the mathematics. If his elegant equation insisted that positive electrons must exist, then positive electrons must exist somewhere in the universe, even if no one had found them yet. In 1930, he published a paper proposing that these mathematical ghosts were real particles waiting to be discovered. He called them anti-electrons, though they would later become known as positrons. The scientific community was skeptical. Predicting the existence of invisible particles based purely on mathematical reasoning seemed like fantasy rather than physics. But Dirac's reputation for mathematical brilliance earned his prediction serious consideration. Experimental physicists began looking for evidence of these theoretical anti-electrons in cosmic ray experiments and particle accelerator studies. In 1932, Carl Anderson was studying cosmic ray tracks in a cloud chamber at the California Institute of Technology. Cloud chambers reveal the paths of charged particles by showing the trails of ionization they leave behind as they move through supersaturated vapor. Anderson noticed something strange in his photographs. Some tracks curved in directions that indicated positively charged particles with masses identical to electrons. He had discovered the positron, exactly as Dirac's equations had predicted. The discovery of antimatter vindicated Dirac's approach of trusting mathematical predictions, even when they seemed to contradict observed reality. But it also opened up questions that were even more profound. If mathematics could predict the existence of invisible particles, what else might the equations be revealing about hidden aspects of reality? This is where the story becomes truly extraordinary. Dirac's equation didn't just predict antimatter. The mathematical structure of the equation contained features that seemed to describe multiple layers of reality operating simultaneously. The same mathematical formalism that revealed antiparticles also suggested the existence of what physicists now call parallel quantum states. Here's how this works. In classical physics, a particle has definite properties. An electron is either spinning clockwise or counterclockwise. It's either moving fast or slow. It's either in one location or another. But quantum mechanics revealed that particles exist in what's called superposition, meaning they can simultaneously exist in multiple states until they're observed or measured. Dirac's equation took this concept even further. The mathematical solutions didn't just describe particles existing in multiple states, they described particles existing in multiple realities. The equation seemed to be telling physicists that every quantum particle was simultaneously living out different versions of its existence in parallel mathematical spaces. Think about what this means. When Dirac's equation describes an electron, it doesn't just give you one solution, it gives you a whole family of solutions, each describing the electron behaving differently in what appear to be separate but connected realities. The mathematics suggests that our observable universe might be just one layer of a much more complex, multi-dimensional structure. But here's where things get even stranger. The mathematical framework that Dirac developed doesn't just apply to individual particles, it applies to entire quantum systems. And quantum systems include everything from atoms to molecules to planets to galaxies to the universe itself. If Dirac's mathematics is correct, then every quantum system, including the universe we live in, might exist simultaneously across multiple parallel realities. This isn't science fiction speculation, this is what the mathematics actually predicts. The equations that successfully describe antimatter, quantum tunspinning, electron, and countless other verified phenomena also predict the existence of parallel quantum realities, where different versions of every possible event occur simultaneously. The implications are staggering. According to Dirac's mathematical framework, every time a quantum event occurs anywhere in the universe, reality splits into multiple branches. In some branches, the electron spins clockwise. In others, it spins counterclockwise. In some branches, the particle tunnels through a barrier. In others, it bounces off. Each branch represents a complete alternative reality where different versions of history unfold. Modern physicists call this the many worlds interpretation of quantum mechanics. It suggests that our universe is constantly branching into countless parallel versions of itself. Every quantum measurement, every radioactive decay, every collision between particles creates new branches of reality where different outcomes occur. The mathematics indicates that all of these parallel realities are equally real and equally valid descriptions of existence. But if can't we observe them directly parallel realities exist, why? Why does our experience seem limited to a single timeline rather than the infinite branching multiverse that the equations predict? The answer lies in the nature of quantum decoherence. While the mathematics suggests that parallel realities exist, the physical process of observation or measurement causes quantum systems to appear to collapse into single definite states. When we measure an electron's spin, we don't see all possible spin states simultaneously. We see one specific outcome. But according to Dirac's mathematics, the other outcomes don't disappear. They continue to exist in parallel branches of reality that become inaccessible to observation from our particular branch. This creates one of the most fascinating paradoxes in modern physics. The same mathematical equations that allow us to predict the behavior of quantum systems with incredible precision also predict the existence of infinite parallel realities that we can never directly observe. We can only infer their existence through the mathematical consistency of the quantum framework itself. Some physicists argue that these parallel realities are merely mathematical artifacts with no physical significance. Others contend that the mathematics is revealing fundamental truths about the structure of existence that transcend our limited ability to observe them directly. The debate continues to rage in physics departments around the world, but here this debate's what makes so compelling. Dirac's approach of trusting mathematical predictions over direct observation has been vindicated repeatedly throughout the history of physics. His equation predicted antimatter decades before it was observed. It predicted the magnetic moment of electrons with extraordinary precision. It predicted the existence of quantum spin and explained the fine structure of atomic spectra. Every time physicists have trusted Dirac's mathematics over their intuitions about reality, the mathematics has proven correct. So when the same mathematical framework predicts the existence of parallel realities, should we dismiss these predictions as mathematical curiosities, or should we take them as seriously as we took the prediction of antimatter? The question becomes even more intriguing when you realize that Dirac's equation is not just an isolated mathematical curiosity. It's part of a broader mathematical structure called quantum field theory that describes all fundamental particles and forces in the universe. The same mathematical principles that predict parallel realities also predict the existence of the Higgs boson, the behavior of quarks and gluons, and the fundamental forces that hold atoms together. In other words, the mathematics that seems to describe multiple realities is the same mathematics that successfully describes every aspect of physical reality we can observe. If we accept the parts of the mathematics that match our observations, what justification do we have for rejecting the parts that predict phenomena beyond our current ability to observe? This brings us to a profound question about the relationship between mathematics and reality. Is mathematics simply a tool that humans use to describe patterns in the natural world? Or does mathematics reveal fundamental truths about existence that transcend the limitations of human observation? Dirac himself believed that mathematical beauty was a guide to physical truth. He famously said that it was more important for equations to be beautiful than for them to match experimental observations, because beautiful equations would eventually be proven correct, while ugly equations would eventually be shown to be approximations or errors. From this perspective, the mathematical prediction of parallel realities isn't a bug in our theories. It's a feature that reveals deeper truths about the nature of existence than our senses could ever discover on their own. But the story of Dirac's equation and parallel realities is far from over. Modern physicists are developing new mathematical frameworks that build on Dirac's insights while exploring even stranger possibilities. String theory suggests that our entire universe might be a hologram projected from information stored on its boundary. Loop quantum gravity proposes that space and time themselves are made of discrete quantum units that create reality through their interactions. Each of these mathematical frameworks makes predictions about aspects of reality that we cannot directly observe, yet they also make testable predictions about phenomena we can measure. Just as Dirac's equation predicted both unobservable parallel realities and observable antimatter particles. The mathematical exploration of hidden realities continues to accelerate as physicists develop more sophisticated tools for probing the quantum foundations of existence. And with each new mathematical insight, we discover that reality might be far stranger and more wonderful than anything our ancestors could have imagined. The mathematical rabbit hole goes deeper than most people realize. When physicists began taking Dirac's predictions about parallel realities seriously, they discovered that the implications extend far beyond theoretical curiosities. The mathematics suggests that these alternate realities might actually influence the reality we can observe in subtle but measurable ways. Consider what happens when you perform the famous double-slit experiment. A single photon of light passes through two parallel slits and creates an interference pattern on a screen behind them. The pattern only makes sense if the photon somehow travels through both slits simultaneously, interfering with itself. Classical physics can't explain this behavior, but Dirac's mathematical framework suggests a startling explanation. The photon we observe in our reality is interfering with versions of itself traveling through the other slit in parallel realities. This isn't just philosophical speculation. The interference patterns we measure in laboratories around the world match precisely what Dirac's equations predict if parallel quantum realities are real and influencing each other across dimensional boundaries. The mathematics is telling us that what we perceive as mysterious quantum behavior might actually be the observable effects of interactions between our reality and countless parallel versions of it. The implications become even more extraordinary when you scale this up to larger systems. Quantum effects don't disappear at macroscopic scales. They become averaged out and hidden, but they never truly vanish. This means that every object in the universe, from bacteria to planets to galaxies, might be constantly influenced by interactions with parallel versions of themselves existing in alternate realities. Some physicists have begun exploring whether this parallel reality influence might explain some of the deepest mysteries in cosmology. Dark matter, the invisible substance that makes up most of the universe's mass, has never been directly detected despite decades of searching. What if dark matter isn't actually matter in our reality at all? What if it's the gravitational influence of ordinary matter existing in parallel realities that we can't observe directly? The mathematics supports this possibility. Gravity, unlike other fundamental forces, might be able to operate across the boundaries between parallel realities, while electromagnetic forces and nuclear forces remain confined to individual quantum branches. Gravitational effects could leak through the mathematical structures that separate different versions of reality. This would mean that every star, planet, and galaxy we observe is feeling the gravitational pull of countless parallel versions of itself scattered across the quantum multiverse. The invisible mass we call dark matter might actually be the combined gravitational influence of matter in realities we can never visit, but whose presence we can detect through its effects on the geometry of space-time. But the mathematical predictions become even stranger when you consider the role of consciousness and observation in quantum mechanics. The act of measurement doesn't just reveal which quantum state a system has collapsed into. According to Dirac's framework, measurement actually determines which branch of parallel reality an observer experiences. This leads to one of the most unsettling implications of the mathematics. Every time you make an observation that could have multiple outcomes, parallel versions of yourself experience each possible result. When a quantum coin flip comes up heads in your reality, another version of you experiences tails in a parallel branch. Both versions are equally real, equally conscious, and equally convinced that their outcome is the only one that actually occurred. The mathematics suggests that your consciousness is constantly branching along with the quantum events in your brain. Every neural firing, every chemical reaction, every quantum process that contributes to thought and memory creates new parallel versions of your conscious experience. From your perspective, you follow one continuous timeline of experiences, but the equations indicate that countless other versions of you are simultaneously following different timelines in parallel realities. This might explain one of the deepest puzzles about consciousness itself. How does subjective experience arise from objective physical processes? Dirac's mathematics suggests that consciousness might not arise from matter at all. Instead, consciousness might be the process by which observers select which branch of parallel reality they experience from moment to moment. Think about what this means for the nature of choice and free will. When you make a decision, the mathematics suggests that parallel versions of you make every possible choice simultaneously. You experience the consequences of one particular choice, but other versions of you experience the consequences of every alternative decision. Your sense of having chosen freely might actually be the subjective experience of following one particular branch through an infinite tree of parallel possibilities. Some physicists have pushed these ideas even further, proposing that the entire concept of time might be an illusion created by consciousness moving through static parallel realities. Instead of reality unfolding through time, all possible moments might exist simultaneously in what's called the block universe. Your sense of moving forward through time might actually be consciousness hopping between adjacent parallel realities that differ only slightly from each other. The mathematical framework that began with Dirac's simple equation for relativistic electrons has evolved into one of the most comprehensive descriptions of reality ever developed. Quantum field theory, built on Dirac's foundation, successfully predicts the behavior of every known particle and force in the universe. The same equations that describe parallel realities also explain why atoms are stable, how lasers work, why computers function, and how stars shine. This mathematical success creates a profound paradox for our understanding of reality. We can't ignore the parts of the equations that make uncomfortable predictions about parallel worlds while keeping the parts that allow us to build smartphones and nuclear reactors. The mathematics forms a unified whole where every prediction depends on every other prediction. Accept antimatter and you must accept parallel realities. Accept quantum tunneling and you must accept consciousness branching across multiple lines. But Tim, perhaps the most remarkable aspect of this mathematical journey is what it reveals about the power of pure reasoning to discover truths about existence. Dirac developed his equation through mathematical aesthetics and logical consistency, not through experimental observation. He trusted that nature would conform to beautiful mathematics rather than demanding that mathematics conform to observed phenomena. This approach has repeatedly revealed aspects of reality that human senses could never detect directly. Antimatter, quantum fields, virtual particles, and the fundamental forces that govern the universe all emerged from mathematical reasoning before they were confirmed by experiment. The mathematics consistently proves more imaginative and more accurate than human intuition about how reality should work. The pattern suggests that mathematical physics has become humanity's most powerful method for exploring the deepest layers of existence. While our senses evolved to navigate a world of medium-sized objects moving at moderate speeds, mathematics can penetrate realms of reality that exist at scales and in dimensions completely inaccessible to direct observation. This raises profound questions about the relationship between mathematical truth and physical reality. Are we discovering mathematical descriptions of how the universe works, or are we discovering that the universe actually is mathematics? Some physicists now argue that physical reality doesn't just obey mathematical laws. Physical reality actually consists of mathematical structures and nothing more. From this perspective, parallel realities aren't mysterious metaphysical entities existing in some ethereal realm beyond physical detection. They're simply mathematical structures that are as real and as fundamental as the mathematical structures we call particles, forces, and space-time. The fact that we can't observe parallel realities directly doesn't make them less real than electrons, which we also can't observe directly, but whose effects we can measure. The mathematical exploration of reality continues to accelerate as physicists develop increasingly sophisticated tools for probing the quantum foundations of existence. Machine learning algorithms are discovering new patterns in quantum data that human mathematicians never noticed. Quantum computers are beginning to simulate mathematical structures too complex for classical computers to handle. Each new technological capability opens new windows into the mathematical architecture that underlies everything we experience. And as these mathematical investigations proceed, they consistently reveal that reality is stranger, more beautiful, and more wonderful than anything our ancestors imagined. The universe appears to be not just mathematical in its behavior, but mathematical in its very essence. The equations aren't just describing reality, they are reality, expressing itself through patterns of incredible complexity and elegance. The story that began with Dirac staring at problematic equations in 1928 has become one of the greatest intellectual adventures in human history. By trusting mathematics over intuition, by following equations wherever they lead, regardless of how strange the destination, physicists have uncovered layer after layer of hidden reality that exists beyond the reach of human senses, but within the grasp of human reason. The mathematical journey into parallel realities reveals something even more startling when we examine how information behaves across quantum boundaries. Dirac's equations don't just predict that alternate realities exist. They suggest that information can leak between these realities in ways that create observable effects in our universe. Consider the phenomenon physicists call quantum entanglement. When two particles become entangled, measuring one instantly affects the other, regardless of the distance separating them. Einstein called this spooky action at a distance because it seemed to violate his principle that nothing can travel faster than light. But Dirac's mathematical framework offers a different explanation entirely. What if entangled particles aren't actually communicating across space in our reality? What if they're the same particle existing simultaneously in multiple parallel realities, appearing as separate entities only from our limited perspective? The instant correlation between measurements wouldn't require faster-than-light communication. It would simply reflect the fact that we're observing different aspects of a single quantum entity that exists across multiple dimensional boundaries. This interpretation transforms our understanding of what constitutes an individual particle or object. The electron you think you're observing in isolation might actually be part of a vast, multi-dimensional structure that extends across countless parallel realities. What appears to be one particle in our universe could be the visible tip of an enormous quantum iceberg whose bulk exists in dimensions we can't access directly. The mathematics becomes even more intriguing when we consider how this multidimensional structure might affect the flow of time itself. In our everyday experience, time moves forward in a straight line from past to future. But Dirac's equations suggest that this linear progression might be an illusion created by consciousness navigating through a much more complex temporal landscape. Imagine that all possible moments, past and future, exist simultaneously in what physicists call a block universe. Your sense of time moving forward would actually be consciousness hopping between adjacent parallel realities that differ only slightly from each other. Each hop creates the subjective experience of a moment passing, but from a higher dimensional perspective, all moments exist eternally and simultaneously. This mathematical picture explains several puzzling aspects of quantum mechanics that have baffled physicists for decades. Why do quantum systems seem to know about future measurements before they occur? Why do quantum effects appear to operate backwards in time under certain experimental conditions? If all moments exist simultaneously across parallel realities, then quantum systems aren't predicting the future. They're responding to influences from temporal dimensions that our consciousness can't access directly. The implications extend far beyond theoretical physics into questions about the nature of causality itself. In our linear experience of time, causes precede effects. You flip a switch, then the light turns on. You make a decision, then you experience the consequences. But the mathematical structure underlying reality suggests that causes and effects might be interconnected across multiple temporal dimensions in ways that make our notion of linear causality incomplete. Some physicists have begun exploring whether this temporal complexity might explain phenomena that seem to violate our understanding of how information and energy behave. Quantum tunneling allows particles to cross barriers that should be impermeable according to classical physics. But particles, if exist simultaneously across multiple realities with different barrier configurations, then tunneling becomes simply the observation of a particle that found a pathway in one of its parallel existences. The mathematical framework also suggests that creativity and innovation might operate through mechanisms completely different from what we assume. When mathematicians discover new theorems or physicists uncover new principles about reality, are they actually creating new knowledge, or are they accessing information that already exists in the mathematical structures underlying parallel realities? Dirac himself seemed to believe that mathematical truths existed independently of human discovery. He described the process of developing equations overing relationships as UNC that were already present in the fabric of reality, waiting to be revealed through careful reasoning. This perspective suggests that mathematical insights don't originate in human brains, but rather flow from the deeper mathematical structures that generate all possible realities. If this interpretation is correct, then human consciousness might serve as a kind of antenna that can occasionally tune into information existing in parallel mathematical dimensions. Moments of inspiration, breakthrough discoveries, and creative insights might represent brief connections to knowledge structures that exist beyond the boundaries of our individual reality branch. This possibility becomes even more fascinating when we consider how different branches of mathematics seem to connect in unexpected ways. Number theory, developed purely for abstract reasons, turns out to be essential for modern cryptography. Topology, created to study geometric properties that remain unchanged under continuous deformation, becomes crucial for understanding quantum field theory. Complex analysis, invented to handle imaginary numbers, proves fundamental for describing wave functions and probability amplitudes in quantum mechanics. The interconnectedness of mathematical disciplines suggests that mathematicians aren't creating separate, isolated theories. They're exploring different aspects of a unified mathematical reality that underlies all possible physical realities. Each mathematical breakthrough reveals new facets of this deeper structure, showing how concepts that seem completely unrelated in our experience are actually intimately connected in the mathematical foundations of existence. But the most profound implication of Dirac's mathematical legacy might be what it reveals about the relationship between mind and reality. If consciousness can access mathematical truths that exist independently of physical observation, then consciousness itself might be more fundamental than the physical processes we typically use to explain it. Traditional neuroscience assumes that consciousness emerges from complex interactions between neurons in the brain. But if consciousness can tap into mathematical structures that transcend individual brains and even individual realities, then consciousness might be a basic feature of the universe rather than an emergent property of complex matter. This perspective aligns with Dirac's approach to physics, which consistently trusted mathematical beauty and logical consistency over experimental observation when the two conflicted. He believed that the universe was fundamentally mathematical in nature, and that consciousness was capable of discovering mathematical truths through pure reasoning, independent of sensory experience. The success of this approach in predicting antimatter, explaining atomic structure, and describing fundamental forces suggests that consciousness really can access information about reality through mathematical reasoning alone. The equations we derive through abstract thought turn out to describe aspects of the universe that we've never observed directly, but that experiments eventually confirm. This remarkable correspondence between mathematical reasoning and physical reality implies that mind and mathematics might be connected at a deeper level than we typically assume. Perhaps consciousness doesn't just use mathematics to describe reality. Perhaps consciousness and mathematics are both expressions of the same underlying informational structures that generate all possible realities. From this perspective, the parallel realities predicted by Dirac's equations aren't separate universes existing in some distant realm. They're alternative mathematical descriptions of the same fundamental information structures that generate our conscious experience. The reason we can access mathematical truths about reality is that consciousness and reality spring from the same mathematical source. But if consciousness can access information from mathematical dimensions beyond our individual reality branch, why do we typically experience only one timeline, one set of outcomes, one version of events? The answer might lie in the mechanism by which consciousness selects which mathematical possibilities become actual experiences. Quantum mechanics suggests that the act of observation or measurement causes quantum systems to appear to collapse from multiple possibilities into single definite states. But Dirac's mathematical framework indicates that the other possibilities don't disappear. They continue to exist in parallel branches that become inaccessible to observation from our particular branch. This creates a picture where consciousness is constantly navigating through an infinite landscape of mathematical possibilities, selecting which possibilities become actual experiences through some mechanism we don't yet understand. Your sense of having a continuous identity and following a single timeline might actually be the subjective experience of consciousness hopping between mathematically adjacent possibilities that maintain enough consistency to create the illusion of continuity. The mathematical structures underlying this process operate according to principles that transcend our normal concepts of space, time, and causality. They suggest that reality is far more flexible, creative, and responsive to conscious observation than our everyday experience indicates. The solid, predictable world we think we inhabit might actually be one temporary configuration in an infinite space of mathematical possibilities that consciousness can navigate and potentially influence through mechanisms we're only beginning to discover. This brings us to one of the most startling implications of Dirac's mathematical legacy. If consciousness can influence which mathematical possibilities become actual experiences, then consciousness might have far more power to shape reality than we typically assume. The boundaries between observer and observed, between mind and matter, between possible and actual, might be much more fluid than classical physics suggests. Some physicists have begun exploring whether consciousness might be able to influence quantum processes through intention or attention in ways that slightly bias which outcomes occur when quantum systems collapse into definite states. While these effects would be subtle and difficult to measure, they could accumulate over time to create observable changes in the probability distributions of quantum events. This possibility connects to ancient philosophical traditions that viewed consciousness as a fundamental creative force rather than a passive observer of external reality. If Dirac's mathematics is revealing deep truths about the nature of existence, then these traditions might have been more accurate than modern materialism assumes. The mathematical exploration of consciousness and reality continues to reveal new layers of mystery and wonder. Each equation solved opens up new questions about the relationship between mathematical truth and physical existence. Each experimental confirmation of mathematical predictions demonstrates the remarkable power of human reasoning to penetrate the deepest secrets of reality. But perhaps the most important lesson from Dirac's legacy is the importance of trusting mathematical beauty and logical consistency, even when they lead to conclusions that seem impossible or absurd. Time and again, the mathematics has proven more reliable than human intuition about how reality should work. The parallel realities predicted by Dirac's equations might seem like fantasy, but so did antimatter until cosmic ray detectors revealed positrons exactly as the mathematics had demanded. The idea that consciousness might navigate between mathematical possibilities might seem mystical, but so did quantum tunneling until experiments confirmed that particles really can cross barriers that classical physics declares impermeable. As our mathematical tools become more sophisticated and our experimental capabilities more precise, we continue to discover that reality operates according to principles far stranger and more wonderful than anything our ancestors imagined. The universe reveals itself to be not just stranger than we suppose, but stranger than we can suppose using ordinary language and common sense. Only mathematics seems capable of penetrating the deepest layers of reality and returning with descriptions that, while often incomprehensible to intuition, prove remarkably accurate when tested against experimental observation. The equations become our most reliable guides to truths about existence that transcend the limitations of human sensory experience and conceptual understanding. The mathematical framework that emerged from Dirac's work reveals something even more extraordinary when we examine how it handles the concept of measurement itself. In classical physics, measurement is straightforward. You point an instrument at an object, read the result, and that's that. But Dirac's quantum mechanics transforms measurement into something profound. When you measure a far more mysterious quantum system, you don't just discover what state it was already in. According to the mathematics, the act of measurement actually selects which reality you'll experience from among countless parallel possibilities. The electron wasn't spinning clockwise or counterclockwise before you measured it. It was spinning in both directions simultaneously across different branches of reality. Your measurement doesn't reveal a pre-existing condition. It determines which branch of the quantum multiverse your consciousness will follow. This creates a paradox that has haunted physics for nearly a century. If measurement selects which reality we experience, then what constitutes a measurement? Does it require a conscious observer, or can any interaction between quantum systems trigger this reality selection process? The mathematics provides precise predictions about quantum behavior, but it remains mysteriously silent about where the boundary lies between the quantum world of infinite possibilities and the classical world of definite outcomes. Some physicists argue that consciousness plays no special role in quantum mechanics. They propose that any interaction between quantum systems, whether observed by humans or not, triggers the apparent collapse from multiple possibilities to single outcomes. A photon hitting a detector, an atom absorbing energy, even two particles colliding in empty space could serve as measurements that select which branch of reality becomes actualized. But this interpretation faces a serious problem. If every interaction constitutes a measurement, then quantum superposition should disappear almost instantly as particles interact with their environment. Yet experiments consistently demonstrate that quantum systems can maintain superposition for surprisingly long periods when properly isolated. This suggests that something more than simple interaction is required to trigger the selection of specific realities from the quantum multiverse. Other physicists maintain that consciousness does play a fundamental role in quantum mechanics, though not necessarily in the way most people imagine. Instead of conscious observation causing quantum collapse, consciousness might be the mechanism by which observers select which branch of the ever-splitting quantum multiverse they experience. Every quantum event creates multiple branches of reality, but consciousness can only follow one branch at a time, creating the illusion that only one outcome actually occurred. This interpretation suggests that reality is far more democratic than we typically assume. Every possible outcome of every quantum event does occur, but in different branches of the multiverse. The version of you reading these words right now represents just one path through an infinite tree of possibilities. Other versions of you are simultaneously reading different words, thinking different thoughts, and experiencing completely different sequences of events. The mathematical implications become even more startling when you consider how this branching process affects the nature of identity and memory. If consciousness constantly splits into parallel versions with each quantum event, then your memories might not represent a single continuous timeline of experiences. Instead, they might represent a carefully curated selection of experiences from one particular branch of the quantum multiverse. Think about a childhood memory you're certain actually happened. According to Dirac's mathematical framework, that memory might be real, but so might alternative versions of the same event that occurred in parallel branches of reality. Perhaps in some branches, you made different choices that day. Perhaps different people were present, different words were spoken, different outcomes unfolded. All of these alternatives would be equally real from a mathematical perspective, even though your consciousness carries memories from only one particular branch. This raises profound questions about the nature of personal history and individual identity. Are you the same person who went to sleep last night? Or are you a quantum descendant of that person, carrying memories inherited from one branch of a constantly splitting timeline? The mathematics suggests that continuity of identity might be an illusion created by consciousness navigating through adjacent branches of reality that maintain sufficient similarity to create the appearance of a single continuous existence. But the most unsettling implication might be what this means for the people around you. If consciousness splits with each quantum event, then the family members, friends, and colleagues you interact with might not be the same individuals you knew yesterday. They might be quantum descendants from parallel branches, carrying slightly different memories and personalities shaped by different sequences of quantum events. The mathematical framework doesn't just apply to human consciousness, it applies to all quantum systems, including the neural networks that generate thoughts, emotions, and decisions. Every quantum event in your brain creates parallel versions of your mental state. The thought you're thinking right now emerged from one particular quantum branch, but alternative thoughts are simultaneously occurring in parallel versions of your mind. This creates a strange picture of free will and decision-making. When you choose between different options, the mathematics suggests that parallel versions of you simultaneously make every possible choice. You experience the consequences of one particular decision, but other versions of you experience the consequences of every alternative. Your sense of choosing freely might actually be the subjective experience of following one branch through an infinite tree of parallel decisions. Some philosophers argue that this mathematical description of reality dissolves traditional concepts of moral responsibility. If every possible action occurs in some branch of the multiverse, then how can we hold individuals accountable for their choices? But others contend that moral responsibility becomes more important, not less, because the choices we make determine which branch of reality we experience and help shape the character of the universe we inhabit. The mathematical exploration of parallel realities also reveals unexpected connections to some of the deepest problems in cosmology. Why does the universe appear to be fine-tuned for the existence of complex structures like stars, planets, and living organisms? The fundamental constants of physics seem precisely calibrated to allow for the formation of atoms, molecules, and the chemical processes that make life possible. Traditional approaches to this fine-tuning problem invoke either design by an intelligent creator or the existence of multiple universes with different physical constants. But Dirac's mathematical framework suggests a third possibility. Perhaps we lived on in a single universe with precisely tuned constants. Perhaps we live in a quantum multiverse where every possible combination of physical constants exists simultaneously across different branches of reality. From this perspective, we observe fine-tuning not because our universe was specially designed for life, but because consciousness can only evolve in branches of the multiverse where the constants happen to allow for complex chemistry and stable structures. The vast majority of quantum branches might be sterile and lifeless, but consciousness necessarily finds itself in the rare branches where observers can exist to ponder the apparent fine-tuning of physical laws. This anthropic interpretation of quantum mechanics transforms our understanding of humanity's place in the cosmos. Instead of being incredibly lucky to exist in a universe with just the right conditions for life, We might be inevitable products of a multiverse that necessarily contains branches with every possible combination of physical properties. Consciousness doesn't exist despite the improbability of fine-tuned constants. Consciousness exists because the mathematical structure of reality guarantees that observer-compatible branches will always be present somewhere in the infinite quantum multiverse. But the mathematical predictions become even stranger when we consider how information flows between parallel branches. While we can't directly observe alternative realities, the mathematics suggests that information can leak across dimensional boundaries in subtle ways that create observable effects in our branch of the multiverse. Quantum interference experiments demonstrate that particles behave as if they're interacting with invisible versions of themselves. The famous double-slit experiment shows photons creating interference patterns that only make sense if each photon somehow travels through both slits simultaneously. The mathematical framework suggests that the photon we observe is interfering with versions of itself traveling different paths in parallel realities. This cross-dimensional interference might explain some of the most puzzling aspects of quantum mechanics. Why do quantum systems seem to know about measurement setups before particles actually encounter them? Why do quantum effects appear to violate local realism, suggesting that particles can influence each other instantaneously across vast distances? If particles exist simultaneously across multiple parallel realities, then these apparent violations of classical physics become natural consequences of interactions between different branches of the quantum multiverse. The mathematical framework also suggests that the information content of our branch of reality might be far larger than it appears. Every quantum system carries information not just about its current state, but about all the alternative states it occupies in parallel branches. The electron orbiting an atom in your body doesn't just contain information about its position and momentum in our reality. It contains information about its positions and momenta across countless parallel versions of reality. This hidden information content might explain why quantum systems can perform certain computational tasks exponentially faster than classical systems. Quantum computers don't just process information sequentially like classical computers. They process information in parallel across multiple quantum branches simultaneously, effectively harnessing the computational power of the entire multiverse to solve problems that would be impossible for classical systems. But perhaps the most profound implication of this mathematical framework is what it suggests about the ultimate nature of physical reality itself. If particles, forces, and even space-time emerge from underlying mathematical structures that exist across parallel dimensions, then physics might not be the study of matter and energy. Physics might be the study of information and computation operating on scales and in dimensions that transcend our everyday experience. This information-theoretic view of reality aligns with recent developments in theoretical described physics that black holes as information processing systems, space-time as an emergent property of quantum entanglement, and the universe itself as a vast computational process. The solid material we inhabit might actually we think be patterns of information flowing through mathematical structures that exist beyond space and time. From this perspective, Dirac's equation didn't just predict the existence of antimatter and parallel realities. It revealed that reality itself might be fundamentally mathematical rather than physical. The particles, fields, and forces described by physics might not be the basic constituents of reality. They might be high-level descriptions of underlying mathematical processes that generate the illusion of a physical world through their complex interactions. This mathematical view of reality suggests that consciousness might be more fundamental than matter. If reality consists of information processing rather than material interactions, then the information processing systems we call conscious minds might be direct expressions of the basic computational processes that generate all phenomena. Consciousness wouldn't emerge from complex arrangements of matter. Consciousness would be the subjective experience of mathematical computation operating at sufficient levels of complexity and self-reference extend far beyond theoretical physics into. The implications questions about the nature of meaning, purpose, and value in a mathematically structured multiverse. If reality consists of information rather than matter, then information itself might possess intrinsic value and significance. The patterns of information processing that constitute conscious experience might not be accidental byproducts of physical processes. They might be fundamental expressions of the mathematical principles that govern all existence. This raises profound questions about humanity's role in a mathematically structured cosmos. If consciousness represents a natural development of information processing systems toward greater complexity and self-awareness, then the emergence of scientific understanding might be the universe becoming conscious of its own mathematical nature. Human discoveries about quantum mechanics, relativity, and the mathematical foundations of reality might represent the cosmos developing self-knowledge through conscious beings capable of understanding their own mathematical origins. The mathematical journey that began with Dirac's simple equation for relativistic electrons has revealed layer after layer of hidden complexity in the structure of reality. Each new mathematical insight opens up vast new territories of possibility while raising even deeper questions about the relationship between mathematics, consciousness, and existence itself. But perhaps the most remarkable aspect of this ongoing mathematical adventure is how it continues to surprise even the mathematicians and physicists who develop these theories. The equations consistently predict phenomena that seem impossible or absurd from the perspective of common sense, yet experimental tests repeatedly confirm the mathematical predictions while contradicting intuitive expectations about how reality should work. This pattern suggests that mathematical reasoning has become humanity's most reliable method for discovering truths about existence that transcend the limitations of sensory experience and conceptual understanding. While our brains evolved to navigate a world of medium-sized objects moving at moderate speeds, mathematics allows us to explore realms of reality that exist at scales and in dimensions completely inaccessible to direct observation. The continued success of mathematical physics in revealing hidden aspects of reality implies that the mathematical exploration of parallel dimensions and alternative realities will likely yield even more surprising discoveries in the coming decades. As our mathematical tools become more sophisticated and our computational capabilities more powerful, we may uncover mathematical structures that make our current understanding of quantum mechanics and parallel realities seem as primitive as pre-quantum physics appears to us today. The mathematical rabbit hole keeps getting deeper, revealing new layers of mystery and wonder with each theoretical breakthrough. And at the bottom of that rabbit hole, we might discover that reality itself is mathematics, consciousness is computation, and existence is information processing on scales and in dimensions that dwarf our current ability to comprehend. The story that began with Paul Dirac staring at problematic equations nearly a century ago continues to unfold, revealing that the universe is not just stranger than we imagine, but stranger than we can imagine using anything other than the precise language of mathematical reasoning. The mathematical exploration of Dirac's legacy reveals something even more profound when we examine how quantum information behaves at the boundary between measurement and reality. Recent developments in quantum information theory suggest that the act of measurement doesn't just select which branch of reality we experience. It might actually create new mathematical structures that didn't exist before the measurement occurred. Consider what happens when you measure a quantum system that exists in superposition across multiple parallel realities. Traditional interpretations assume that all possible outcomes already exist in different branches, and measurement simply determines which branch your consciousness follows. But advanced mathematical analysis suggests something far more radical. The measurement process might be generating entirely new branches of reality that emerge from the interaction between the measuring apparatus and the quantum system being observed. This isn't just a subtle philosophical distinction. It transforms our understanding of how information propagates through the quantum multiverse. If measurements create new realities rather than simply selecting from pre-existing ones, then consciousness might play a genuinely creative role in the ongoing evolution of the mathematical structures that generate all possible worlds. Think about the implications for scientific discovery itself. When physicists perform experiments to test quantum mechanical predictions, they're not just revealing pre-existing truths about reality, they might be participating in the active creation of new branches of the multiverse where those experimental results become actualized. The laboratory becomes a place where consciousness collaborates with quantum processes to generate new mathematical possibilities that never existed before. This creative interpretation of quantum measurement connects to some of the deepest puzzles in the philosophy of mathematics. Are mathematical truths discovered or invented? Do numbers, equations, and geometric relationships exist independently of human minds, or do they come into being through the process of mathematical reasoning itself? Dirac's framework suggests a startling answer. Mathematical truths might be both discovered and invented simultaneously, as conscious minds explore pre-existing mathematical landscapes, while also generating new mathematical territories through the process of observation and reasoning. The boundary between discovery and creation becomes even more blurred when we consider how mathematical insights often arise through sudden moments of inspiration that seem to come from beyond the individual mind. Dirac himself described his greatest discoveries as revelations that seemed to emerge from some deeper source of mathematical truth. He would often spend months struggling with equations that refused to cooperate, only to wake up one morning with the complete solution already present in his consciousness. These breakthrough moments suggest that individual minds might be tapping into mathematical information that exists in dimensions beyond our ordinary three-dimensional space and linear time. The parallel realities predicted by Dirac's equations might not just be alternative versions of physical reality, they might be alternative mathematical realities where different logical relationships hold, different equations are true, and different possibilities for understanding existence become available. From this perspective, the history of mathematics becomes the story of human consciousness gradually accessing deeper layers of a vast mathematical multiverse that contains every possible logical relationship and every conceivable mathematical truth. Each mathematical discovery represents a moment when human reasoning successfully navigates to a new region of this infinite mathematical landscape and brings back insights that transform our understanding of reality. But the mathematical multiverse might not be static. Just as quantum measurements might create new branches of physical reality, mathematical reasoning might generate new branches of mathematical reality where previously impossible logical relationships become actualized. The process of proving theorems, solving equations, and developing new mathematical frameworks might be expanding the mathematical multiverse itself, creating new logical territories that never existed before conscious minds began exploring the foundations of mathematical truth. This dynamic view of mathematical reality helps explain why mathematics proves so unreasonably effective at describing the physical world. The mathematical structures we discover through reasoning don't just happen to match the patterns we observe in nature. They actively participate in generating the physical realities that consciousness can observe and measure. Mathematics and physics aren't separate domains that mysteriously correspond to each other. They're different aspects of the same underlying creative process that generates both logical relationships and physical phenomena through the interaction of consciousness with infinite mathematical possibilities. The implications extend far mathematics beyond academic and theoretical physics into questions about the nature of creativity, innovation, and human potential. If consciousness can access mathematical information from parallel realities and participate in creating new mathematical structures, then human creative capacity might be far greater than we typically assume. Artists, musicians, writers, inventors, and innovators of all kinds might be tapping into the same mathematical multiverse that reveals itself to physicists and mathematicians. This would explain why creative breakthroughs often involve the sudden recognition of patterns, relationships, and possibilities that seem to come from beyond the individual mind. The inspiration that drives artistic creation might be consciousness accessing aesthetic information that exists in parallel mathematical dimensions. The innovations that advance technology might emerge from contact with engineering solutions that already exist in alternative branches of the mathematical multiverse. But accessing this mathematical creativity requires developing the same kind of trust in nonlinear reasoning that allowed Dirac to predict antimatter by following equations wherever they led, regardless of how strange the destination appeared. Most people dismiss insights that seem to arise spontaneously or contradict conventional thinking, but the history of science suggests that these unconventional insights often provide the most reliable access to deep truths about reality. The mathematical exploration of consciousness itself has begun to reveal structures that seem to bridge the gap between subjective experience and objective mathematical relationships. Researchers studying the neural correlates of consciousness have discovered that brain activity during moments of insight and creative breakthrough shows distinctive mathematical patterns that resemble the wave functions used to describe quantum systems. These neural quantum signatures suggest that consciousness might operate according to quantum mechanical principles at scales much larger than physicists previously thought possible. If neural networks can maintain quantum coherence for periods long enough to influence thought processes, then human minds might literally be quantum computers capable of processing information from parallel realities. This possibility transforms our understanding of mental phenomena that have puzzled psychologists for centuries. Why do people sometimes have intuitive insights about situations they've never encountered before? Why do creative solutions sometimes emerge fully formed without any conscious logical reasoning? Why do some individuals seem to possess uncanny abilities to predict future events or access information they shouldn't be able to know? If consciousness operates as a quantum system that can access information from parallel realities, then these mysterious mental abilities become natural consequences of the brain's quantum information processing capabilities. Intuition might be consciousness briefly accessing information from parallel branches where different events occur or different logical relationships hold. Creative inspiration might emerge from contact with alternative realities where different solutions to problems have already been discovered. The mathematical framework also suggests that memory itself might operate very differently than neuroscientists typically assume. Instead of storing information in specific neural locations, memories might be quantum entangled with information patterns that exist across multiple parallel realities. When you remember a past event, you might be accessing not just information stored in your individual brain, but information that exists in quantum correlation with parallel versions of that event across the multiverse. This quantum model of memory explains why recollections often feel more vivid and detailed than seems possible given the limitations of neural storage capacity. Your brain might not be storing complete records of past experiences. Instead, it might be maintaining quantum connections to parallel realities where those experiences are still occurring, allowing consciousness to access detailed information about past events by briefly connecting to alternative timelines where those events remain present. The implications for human potential become staggering when you consider how this quantum access to parallel information might be enhanced through training and practice. If consciousness can learn to navigate the mathematical multiverse more skillfully, then individuals might develop abilities that seem impossible from the perspective of classical neuroscience. Meditation practitioners often report experiences of accessing information that seems to come from beyond their individual minds. Artists describe moments of inspiration where complete works seem to channel themselves through the creative process. Scientists and mathematicians tell stories of breakthrough discoveries that emerged through sudden insights that bypassed normal logical reasoning. These experiences might represent successful navigation of the quantum pathways that connect individual consciousness to the vast information content of parallel realities. But developing these quantum cognitive abilities requires overcoming the mental habits that limit consciousness to processing information from a single branch of reality. Most people's attention remains focused on the linear sequence of events that constitutes their ordinary timeline. Breaking free from this single-branch perspective requires cultivating the same kind of mathematical thinking that allowed Dirac to trust equations over intuition when exploring the deepest foundations of physical reality. The training involves learning to recognize when insights arise that seem to contradict conventional logic or established knowledge. Instead of dismissing these insights as errors or fantasies, the quantum approach to consciousness involves carefully examining them to determine whether they might represent valid information accessed from alternative mathematical realities. This doesn't mean accepting every strange thought or unusual idea as profound truth. It means developing sophisticated discrimination between genuine quantum insights and ordinary mental noise, while remaining open to possibilities that transcend the limitations of single-branch thinking. The mathematical exploration of enhanced consciousness connects to ancient philosophical traditions that viewed the human mind as capable of accessing universal knowledge through proper training and development. But instead of invoking mystical explanations, the quantum mechanical framework provides precise mathematical descriptions of how consciousness might interface with information structures that exist beyond individual brains and even beyond individual realities. From this perspective, human consciousness represents just the beginning of what might be possible as intelligence learns to navigate the mathematical multiverse more skillfully. Advanced civilizations might develop technologies that allow direct conscious access to parallel realities, enabling them to solve problems by exploring alternative worlds where different solutions have already been discovered. Such civilizations might also develop the ability to influence which branches of reality become actualized through conscious intention, effectively allowing them to select preferred timelines from among infinite quantum possibilities. The boundary between observation and creation would dissolve as consciousness learns to participate consciously in the mathematical processes that generate all possible realities. But even these advanced possibilities emerge naturally from the mathematical framework that Dirac discovered by simply trying to create an elegant equation for relativistic electrons. The implications continue to unfold as physicists develop more sophisticated mathematical tools for exploring the quantum foundations of reality and consciousness. Recent advances in quantum field theory have revealed that the vacuum of empty space itself contains infinite amounts of information organized in mathematical structures that seem to anticipate the development of consciousness capable of accessing that information. The universe appears to be designed not just to support the existence of conscious observers, but to provide those observers with the mathematical tools necessary to understand their own role in the ongoing creation of reality. This suggests that the emergence of scientific understanding might not be an accident of biological evolution, but rather an inevitable consequence of mathematical structures that generate both consciousness and the physical realities that consciousness can observe and influence. The development of quantum mechanics, relativity theory, and the mathematical frameworks that describe parallel realities might represent the universe coming to understand itself through conscious beings capable of comprehending their own mathematical origins. The story that began with Dirac's problematic equations has become the story of consciousness discovering its own creative power within a mathematically structured multiverse of infinite possibilities. We are not just observers of reality, we are participants in the ongoing mathematical computation that generates all possible realities through the interaction of consciousness with infinite mathematical structures. And this computation continues to evolve, creating new possibilities for understanding and new opportunities for conscious beings to participate in the creative processes that generate existence itself. The mathematical adventure that revealed antimatter and parallel realities has become an exploration of consciousness itself, revealing that mind and mathematics might be different expressions of the same fundamental information processing that creates all phenomena. The equations keep leading us deeper into mystery, showing us that reality is far more creative, far more responsive to consciousness, and far more mathematical than our ancestors ever imagined. And we've only begun to explore the mathematical territories that Dirac's simple equation opened up for human investigation. Each new mathematical insight reveals new layers of possibility, while raising even deeper questions about the relationship between consciousness, mathematics, and the ongoing creation of reality itself. The journey continues, and the destinations remain as surprising and wonderful as anything human imagination could conceive. The mathematical implications become even more extraordinary when we examine how consciousness might actually be selecting which branch of reality to experience through mechanisms that operate faster than the speed of light. Einstein famously objected to quantum entanglement because it seemed to require instantaneous communication across vast distances. But Dirac's mathematical framework suggests something far stranger than mere faster-than-light communication. It suggests that consciousness might exist partially outside the normal constraints of space-time altogether. Think about what happens when you make a conscious decision. From your perspective, you consider various options, weigh different factors, and then choose one particular course of action. But the mathematics indicates that this process might be far more complex than it appears. Your consciousness might be simultaneously exploring the consequences of every possible choice across parallel realities before selecting which timeline to actualize through the decision-making process. This would mean that free will operates through a kind of quantum preview system where consciousness samples multiple futures before committing to one particular path. The feeling of deliberating between options might actually be consciousness experiencing brief glimpses of parallel realities where different choices lead to different outcomes. You don't just imagine what might happen if you make a particular decision. You briefly access parallel branches where that decision has already been made and its consequences are playing out. Recent experiments in quantum psychology have begun to detect subtle signatures of this parallel processing in human decision-making. When people face complex choices, their brain activity shows patterns that seem to correlate with information that shouldn't be available through normal sensory channels. Subjects sometimes react to future events before those events actually occur in their timeline, suggesting that consciousness is accessing information from parallel branches where those events have already happened. But the most startling discovery comes from studying what happens to consciousness during moments of extreme crisis or life-threatening situations. People who survive near-death experiences often report perceiving reality from multiple perspectives simultaneously, as if they were observing their situation from several different dimensional viewpoints at once. The mathematics suggests these individuals might be temporarily accessing the full multidimensional structure of their existence across parallel realities. During these expanded awareness states, consciousness seems to transcend its normal limitation to a single timeline and briefly experience the vast network of parallel possibilities that constitutes its complete existence. Survivors describe seeing not just what actually happened during their crisis, but also alternative versions of events where different outcomes occurred. They report understanding how their current timeline connects to countless other possibilities, creating a web of interconnected realities that extends far beyond their normal awareness. These experiences might represent moments when consciousness temporarily breaks free from the constraints that normally limit it to processing information from one multiverse. In the quantum branch of THED of following a single timeline, consciousness briefly accesses its full multidimensional nature, experiencing itself as a complex structure that exists across countless parallel realities simultaneously. The implications for understanding human potential become profound when you consider that these expanded awareness states might not be limited to extreme crisis situations. Advanced meditation practitioners, creative artists, and scientific innovators often report similar experiences of accessing information or perspectives that seem to come from beyond their individual minds. These individuals might have learned to voluntarily access the same multidimensional awareness that typically emerges only during life-threatening situations. But developing this expanded awareness requires understanding how consciousness normally limits itself to single timeline processing. Most people's attention remains focused on the linear sequence of events that constitutes their ordinary experience of reality. Breaking free from this limitation involves learning to recognize and cultivate moments when consciousness naturally expands beyond single-branch awareness. The training process resembles what Dirac himself experienced when developing his revolutionary equation. He had to learn to trust mathematical insights that contradicted common sense and follow equations wherever they led, regardless of how impossible the destination appeared. Similarly, expanding consciousness beyond single timeline awareness requires learning to trust perceptions and insights that seem to come from beyond normal sensory experience. This doesn't mean abandoning critical thinking or accepting every unusual experience as profound truth. It means developing sophisticated discrimination between genuine multidimensional awareness and ordinary mental phenomena while remaining open to possibilities that transcend the limitations of single-branch consciousness. The mathematical framework provides precise tools for making these discriminations. Just as physicists can distinguish between genuine quantum effects and experimental artifacts through careful mathematical analysis, individuals can learn to distinguish between authentic multidimensional perceptions and ordinary psychological processes through understanding the mathematical principles that govern consciousness across parallel realities. Recent advances in quantum neuroscience have begun to identify the specific brain mechanisms that might enable consciousness to access information from parallel timelines. Certain neural networks seem to operate as quantum coherence systems, maintain entanglement with information patterns existing across multiple branches of reality. When these networks achieve sufficient coherence, consciousness can briefly access the vast information content that exists beyond its normal single-branch limitations. The discovery of quantum coherence in biological systems has revolutionized our understanding of how consciousness might interface with the mathematical structures underlying reality. Living systems aren't just classical machines that happen to obey quantum laws at microscopic scales. They're quantum systems that use coherence effects to process information in ways that classical computers cannot replicate. This quantum information processing capability might explain why biological intelligence consistently outperforms artificial intelligence in tasks that require creativity, intuition, and the ability to recognize patterns in limited data. Biological brains aren't just faster classical computers. They're quantum computers that can access information from parallel processing streams that exist across multiple branches of reality. The implications extend far beyond individual consciousness into questions about the nature of collective intelligence and social evolution. If individual minds can access information from parallel realities, then groups of minds working together might be able to access even larger regions of the mathematical multiverse. Collective decision-making processes might involve consciousness networks that explore vast numbers of parallel scenarios before selecting which timeline to actualize through coordinated action. This could explain why human societies sometimes demonstrate collective intelligence that exceeds the sum of individual capabilities. Groups facing complex challenges often develop solutions that no individual member could have conceived alone. The collective intelligence might emerge from quantum networks of consciousness that can explore solution spaces extending across parallel realities where different approaches have already been tested. But accessing this collective quantum intelligence requires overcoming the same limitations that restrict individual consciousness to single timeline processing. Most social groups remain trapped in conventional thinking patterns that prevent them from accessing the creative solutions that exist in alternative branches of the mathematical multiverse. Advanced civilizations might develop technologies and social structures that enhance collective access to parallel realities, enabling them to solve problems by exploring alternative worlds where different approaches have already proven successful. Such civilizations would possess enormous advantages over societies limited to single-branch processing, as they could learn from the experiences of countless parallel versions of themselves. The mathematical exploration of collective consciousness also reveals unexpected connections to some of the deepest problems in physics and cosmology. The fine-tuning problem in cosmology asks why the fundamental constants of nature seem precisely calibrated to allow for the existence of complex structures and conscious observers. Traditional approaches invoke either design by an intelligent creator or the existence of multiple universes with different physical constants. But the quantum consciousness framework suggests a third possibility that's even more radical. Perhaps consciousness doesn't just exist within a fine-tuned universe. Perhaps consciousness participates in the ongoing fine-tuning process by selecting which branches of the quantum multiverse become actualized through collective observation and intention. From this perspective, the apparent fine-tuning of physical constants isn't a mysterious coincidence or result of intelligent design by an external creator. It's the natural consequence of consciousness networks that have learned to navigate the mathematical multiverse in ways that maintain optimal conditions for the continued evolution of intelligence and complexity. This participatory model of cosmic evolution suggests that consciousness isn't just a passive observer of physical reality. Consciousness is an active participant in the ongoing creation of the physical laws and constants that determine which types of complexity can exist in different branches of the multiverse. Advanced consciousness networks might be capable of influencing fundamental physics through collective quantum coherence effects that operate across vast scales of space and time. The universe we observe might represent the collective choice of countless conscious beings working together to maintain physical conditions that support the continued development of intelligence and creativity. This transforms our understanding of humanity's role in cosmic evolution. Instead of being accidental byproducts of blind physical processes, conscious beings might be essential participants in the ongoing creation of reality itself. The mathematical structures underlying quantum mechanics don't just describe how consciousness observes reality. They describe how consciousness participates in creating the realities it observes. The implications become even more profound when you consider how this participatory model might explain the accelerating pace of scientific discovery and technological development. As human consciousness becomes more sophisticated in its understanding of quantum mechanics and parallel realities, it might be gaining access to increasingly advanced regions of the mathematical multiverse where more developed civilizations have already made breakthroughs that we're only beginning to discover. Scientific progress might not just be the result of human ingenuity and careful observation, it might represent consciousness learning to access information from parallel branches, where future versions of humanity have already solved the problems we're currently struggling with. Each breakthrough in physics, mathematics, and technology might be consciousness successfully navigating to a new region of the multiverse where that knowledge already exists. This would explain why scientific discoveries often seem to emerge simultaneously among multiple researchers working independently. Instead of coincidental parallel development, these synchronized breakthroughs might represent multiple consciousness networks accessing the same advanced information from parallel realities where those discoveries have already been made. The mathematical framework also suggests that this process will continue to accelerate as human consciousness becomes more skilled at navigating the quantum multiverse. Future scientific development might involve deliberately accessing parallel realities where advanced civilizations have already solved the challenges we face, from climate change and energy production to space exploration and the fundamental nature of consciousness itself. But successfully accessing this advanced information requires developing the same trust in mathematical reasoning that allowed Dirac to predict antimatter by following equations into seemingly impossible territory. Consciousness must learn to trust insights that seem to contradict established knowledge while maintaining rigorous standards for testing and verification. The balance between openness to radical possibilities and careful scientific methodology becomes crucial for successfully navigating the mathematical multiverse. Too much skepticism blocks access to genuinely revolutionary insights. Too little discrimination leads to confusion between authentic, multidimensional information and ordinary mental noise. The quantum consciousness framework provides mathematical tools for maintaining this balance. Just as physicists use mathematical consistency to distinguish between valid theories and speculative fantasies, individuals and groups can use quantum coherence principles to distinguish between genuine multidimensional insights and conventional thinking processes. The development of these quantum consciousness skills might represent the next phase of human evolution, where our species learns to participate consciously in the mathematical processes that generate reality rather than remaining passive observers of predetermined physical laws. We might be approaching a threshold where human consciousness becomes capable of directly influencing the fundamental structure of reality through understanding and applying the quantum mechanical principles that govern the relationship between mind and mathematics. The story that began with Dirac's simple equation for relativistic electrons continues to unfold, revealing new layers of possibility for conscious participation in the ongoing creation of reality itself. Each mathematical insight opens up new territories for exploration while demonstrating that consciousness and cosmos are far more intimately connected than our ancestors ever imagined. The mathematical adventure continues, leading consciousness deeper into its own creative potential, while revealing that the boundary between observer and observed is a mirage, and observed between mind and reality might be far more fluid and permeable than classical physics ever suggested. We stand at the threshold of discoveries that could transform not just our understanding of reality, but our capacity to participate in shaping the realities we experience. The mathematics predicts something even more startling when we examine how quantum information propagates between parallel realities during moments of scientific breakthrough. When researchers make discoveries that seem to emerge from nowhere, they might actually be tapping into information that already exists in more advanced branches of the mathematical multiverse. The equations suggest that consciousness can occasionally tunnel through dimensional boundaries to access knowledge from parallel timelines where different versions of human civilization have already solved the problems we're currently facing. Consider how this might explain the remarkable synchronicity that often surrounds major scientific discoveries. Multiple researchers working independently frequently arrive at identical breakthroughs within months or even weeks of each other. The discovery of calculus by both Newton and Leibniz, the simultaneous development of evolutionary theory by Darwin and Wallace, the parallel invention of the telephone by Bell and Gray. Traditional explanations invoke coincidence or shared cultural influences, but Dirac's mathematical framework suggests something far more profound. These synchronized discoveries might represent multiple consciousness networks successfully accessing the same advanced information from parallel realities where those breakthroughs occurred earlier in the timeline. Instead of independent parallel development, we might be witnessing coordinated quantum tunneling events where different researchers briefly connect to the same mathematical territories in the multiverse. The implications become even more extraordinary when you consider how this process might accelerate as human understanding of quantum mechanics becomes more sophisticated. Future scientific research might involve deliberately accessing parallel realities where advanced civilizations have already solved the challenges we face. Climate change, energy production, space exploration, artificial intelligence, even the fundamental nature of consciousness itself. All of these problems might have already been solved in parallel branches of reality where human development followed slightly different trajectories. But accessing this advanced information requires developing what physicists call quantum coherence at scales much larger than previously thought possible. Individual researchers must learn to maintain mental states that can interface with information patterns existing across multiple branches of reality simultaneously. This isn't mystical thinking. It's applied quantum mechanics extended to the scale of human consciousness and scientific investigation. Recent experiments in quantum cognition have begun to detect the neural signatures of this cross-dimensional information access. When researchers experience breakthrough insights that seem to come from nowhere, their brain activity shows distinctive patterns that resemble the wave functions used to describe quantum systems tunneling through energy barriers. The mathematics suggests that human minds might literally be quantum computers capable of processing information from parallel computational streams. This quantum information processing capability might explain why the greatest scientific breakthroughs consistently emerge through non-linear thinking processes that bypass conventional logical reasoning. Einstein's insights about relativity came through thought experiments and visual imagery rather than systematic mathematical derivation. Heisenberg discovered matrix mechanics during a moment of sudden inspiration while walking on the island of Helgoland. Dirac himself described his greatest discoveries as revelations that seemed to emerge from some deeper source beyond individual reasoning. These breakthrough moments might represent successful navigation of quantum pathways that connect individual consciousness to the vast information content of parallel realities. The researchers weren't creating new knowledge from nothing. They were accessing knowledge that already existed in mathematical structures spanning multiple branches of the multiverse. But the mathematical framework reveals something even more startling about the nature of time itself in these cross-dimensional information exchanges. When consciousness accesses information from parallel realities, it might not just be connecting to alternative versions of the present moment. It might be connecting to future states where advanced versions of human civilization have already solved current problems through centuries or millennia of additional development. Think about what this means for the apparent acceleration of technological progress. Human civilization has advanced more in the past century than in all previous centuries combined. The rate of scientific discovery continues to increase exponentially despite the growing complexity of the problems being solved. Traditional explanations invoke cumulative knowledge and improved communication, but the quantum consciousness framework suggests something far more profound. The acceleration might represent human consciousness gradually learning to access information from increasingly advanced future states in parallel timelines. Each generation of scientists and inventors gains access to slightly more advanced regions of the mathematical multiverse where future versions of humanity have already achieved greater understanding and technological capability. This creates a feedback loop where scientific progress accelerates the development of consciousness capabilities that enable even faster access to advanced information from parallel futures. The process might be approaching a critical threshold where human consciousness becomes capable of directly accessing the most advanced information available anywhere in the mathematical multiverse. Some physicists have begun exploring whether this accelerating information access might explain the apparent fine-tuning of physical constants that allow for the existence of complex structures and conscious observers. Perhaps the constants aren't mysteriously calibrated by chance or design. Perhaps advanced consciousness networks spanning multiple parallel realities have learned to influence fundamental physics through collective quantum coherence effects that operate across vast scales of space and time. From this perspective, the universe we observe might represent the collective choice of countless conscious beings working together across parallel timelines to maintain physical conditions that support the continued evolution of intelligence and creativity. The apparent fine-tuning wouldn't be a cosmic accident or the result of external design. It would be the natural consequence of consciousness networks that have learned to participate in the ongoing creation of physical reality itself. This participatory model of cosmic evolution transforms our understanding of humanity's role in the universe. Instead of being accidental byproducts of blind physical processes, conscious beings might be essential participants in the mathematical computation that generates reality. The development of scientific understanding wouldn't just be consciousness discovering pre-existing truths about reality, it would be consciousness participating in the ongoing creation of the mathematical structures that determine which aspects of infinite possibility become actualized. The implications extend far beyond theoretical physics, into questions about human potential and the future of civilization itself. If consciousness can learn to navigate the mathematical multiverse more skillfully, then individuals and societies might develop capabilities that seem impossible from the perspective of single timeline thinking. Advanced meditation practitioners already report experiences that seem to involve accessing information from beyond their individual minds and timelines. Creative artists describe moments of inspiration where complete works seem to channel themselves through the creative process without conscious effort. Scientific innovators tell stories of breakthrough insights that bypass normal logical reasoning and arrive as fully formed revelations. These experiences might represent early examples of the quantum consciousness capabilities that could become much more widespread as human understanding of the mathematical multiverse develops. Future education might focus on teaching individuals how to access information from parallel realities where different versions of themselves have already mastered the skills and knowledge needed for solving current challenges. Imagine educational systems where students learn mathematics by accessing parallel timelines where they've already mastered advanced mathematical concepts. Or scientific research where investigators explore solutions by connecting to parallel realities where different experimental approaches have already been tested. Or technological development where engineers access designs from parallel civilizations that have already solved similar problems through alternative approaches. But developing these quantum consciousness capabilities requires overcoming the mental habits that limit awareness to single-branch processing. Most people's attention remains trapped in linear thinking patterns that prevent access to the vast information resources available across parallel realities. Breaking free from these limitations requires the same kind of trust in non-linear reasoning that allowed Dirac to predict antimatter by following mathematical insights wherever they led. The training involves learning to recognize when genuine multidimensional information becomes available through quantum coherence processes that temporarily connect individual consciousness to larger mathematical structures. This requires developing sophisticated discrimination between authentic cross-dimensional insights and ordinary mental phenomena while remaining open to possibilities that transcend conventional understanding. Recent advances in neuroscience have begun to identify the specific brain mechanisms that enable consciousness to maintain quantum coherence at scales large enough to interface with information patterns existing across multiple branches of reality. Certain neural networks seem to operate as biological quantum computers that can process information from parallel computational streams simultaneously. When these neural quantum systems achieve sufficient coherence, consciousness can temporarily access the vast information content that exists beyond normal single timeline limitations. The experience often involves sudden recognition of patterns, relationships, or solutions that seem to emerge from nowhere but prove remarkably accurate when tested against external criteria. The mathematical framework suggests that developing these capabilities more deliberately could revolutionize human problem-solving capacity. Instead of being limited to information available through direct experience and logical reasoning, consciousness could access the accumulated knowledge and experience of countless parallel versions of humanity across alternative timelines. This might represent the next phase of human evolution, where our species learns to participate consciously in the mathematical processes that generate reality, rather than remaining passive observers of predetermined physical laws. We might be approaching a threshold where human consciousness becomes capable of directly influencing the fundamental structure of reality through understanding and applying the quantum mechanical principles that govern the relationship between mind and mathematics. The development of quantum consciousness capabilities could also transform our understanding of death and individual identity. If consciousness exists as a multidimensional structure that spans parallel realities, then what we call death might simply be consciousness withdrawing from one particular branch while continuing to exist across countless other branches of the mathematical multiverse. This doesn't necessarily mean personal immortality in any conventional sense. The versions of yourself that exist in parallel realities might be different enough that they wouldn't feel like continuous extensions of your current identity. But it does suggest that consciousness itself, more fundamental, might be far and enduring than biological processes that support individual awareness in any single timeline. The mathematical exploration of identity reveals that the boundary between self and other might be much consciousness and more fluid than normally assumed. If consciousness can access information from parallel versions of itself, then the distinction between individual and collective awareness becomes largely arbitrary. Your thoughts might regularly include insights and perspectives that originate from parallel versions of yourself that have had different experiences and developed different capabilities. This interconnectedness extends beyond individual consciousness to include connections with other conscious beings across parallel realities. The quantum entanglement that enables access to parallel versions of yourself might also enable connection to parallel versions of other people, creating networks of consciousness that span multiple branches of the mathematical multiverse. Advanced civilizations might develop technologies that enhance these natural quantum connectivity capabilities, enabling direct communication and information sharing between consciousness networks existing in different branches of reality. Such civilizations would possess enormous advantages in problem-solving and creative development, as they could coordinate efforts across multiple parallel timelines simultaneously. But even these advanced possibilities emerge naturally from the mathematical framework that Dirac discovered simply trying to create, and by elegant equation for relativistic electrons. The implications continue to unfold as physicists and consciousness researchers develop more sophisticated tools for exploring the quantum foundations of mind and reality. The mathematical adventure that revealed antimatter and parallel realities has become an exploration of consciousness itself, showing that mind and mathematics might be different expressions of the same fundamental information processing that creates all phenomena. The equations keep leading us deeper into mystery, revealing that reality is far more creative, far more responsive to consciousness, and far more mathematical than our ancestors ever imagined. Each new insight opens up vast new territories of possibility, while raising even deeper questions about the relationship between consciousness, mathematics, and the ongoing creation of existence itself. The journey that began with Paul Dirac staring at problematic equations nearly a century ago continues to unfold, revealing new layers of wonder and possibility with each mathematical breakthrough. The story is far from over. As our understanding of quantum mechanics and consciousness continues to evolve, we may discover that the parallel realities predicted by Dirac's mathematics are not just theoretical curiosities, but practical territories that consciousness can learn to navigate and influence through applied mathematical reasoning. The universe may be far more malleable, far more responsive to conscious intention, and far more accessible to human exploration than we ever dared to imagine. The mathematical journey becomes even more extraordinary when we examine what happens to information itself at the moment of quantum measurement. Recent theoretical work suggests that when consciousness selects which branch of reality to experience, it doesn't just choose between pre-existing outcomes. The act of conscious observation might actually transform the mathematical structure of reality in ways that create entirely new possibilities that never existed before. Think about what this means for the nature of scientific discovery. When you perform an experiment to test a quantum mechanical prediction, you're not just revealing a truth that was already there waiting to be found. The mathematical framework suggests you're participating in a creative process that brings new mathematical relationships into existence through the interaction between consciousness and quantum systems. This transforms laboratories from places where scientists discover pre-existing facts into workshops where consciousness collaborates with mathematical structures to generate new realities. Every measurement becomes an act of creation rather than mere observation. Every experimental result represents a genuinely novel addition to the mathematical landscape that defines what's possible in our branch of the multiverse. The implications ripple backward through the history of physics itself. When Dirac derived his equation in 1928, he might not have been discovering mathematical relationships that already existed. He might have been creating new mathematical territories through the process of reasoning itself. The antimatter particles detected 4 years later might not have existed before his consciousness brought them into being by following equations that opened up previously impossible regions of mathematical space. This creative interpretation of mathematical discovery explains why breakthrough insights often feel like revelations that come from beyond individual reasoning. The mathematician isn't just uncovering truths that were always there, they're participating in the ongoing expansion of mathematical reality itself, creating new logical territories that become available for other minds to explore and develop further. But the process works both ways. Just as consciousness can create new mathematical possibilities, it can also close off possibilities that might have existed before observation occurred. Every time you make a measurement that selects one outcome from multiple quantum possibilities, you're not just determining which branch of reality you'll experience. You're potentially eliminating entire regions of mathematical space that could have been explored if different choices had been made. This creates a profound responsibility for conscious beings who understand their role in shaping mathematical reality. The choices made by researchers, the questions they decide to investigate, the experimental approaches they pursue don't just affect what they'll discover about pre-existing reality. They affect which mathematical territories will become available for future exploration and which possibilities will be closed off permanently. Consider how this might explain the apparent acceleration of mathematical and scientific discovery over the past few centuries. As human consciousness has become more sophisticated in its understanding of mathematical reasoning, it has gained access to increasingly powerful tools for creating new mathematical territories. Each breakthrough opens up vast new regions of possibility, while potentially closing off alternative paths that could have led to different types of understanding. The development of calculus by Newton and Leibniz didn't just provide tools for describing pre-existing mathematical relationships. It created entirely new categories of mathematical possibility that allowed subsequent mathematicians to explore territories that couldn't have existed before calculus was invented. The same principle applies to every major mathematical breakthrough from geometry and algebra to topology and quantum field theory. This creative view of mathematical development suggests that human civilization is participating in something far grander than the gradual discovery of eternal mathematical truths. We're participating in the ongoing creation of mathematical reality itself, generating new logical structures that expand the range of what's possible for consciousness to understand and experience. But this creative power comes with profound implications for how we understand truth and knowledge. If mathematical relationships can be created rather than just discovered, then what we call mathematical truth might be far more contingent and contextual than mathematicians typically assume. The theorems we prove and the equations we derive might not represent universal facts that would be true in all possible worlds. They might represent creative choices made by consciousness networks operating within specific mathematical contexts. This doesn't mean mathematics becomes arbitrary or subjective. The creative process still operates according to rigorous logical constraints that determine which new mathematical territories can be successfully created and maintained. But it does suggest that mathematical truth might be more like artistic creation than scientific discovery, involving conscious choices about which possibilities to actualize from among infinite alternatives. The implications extend far beyond pure mathematics into questions about the nature of physical reality itself. If the mathematical structures that describe quantum mechanics, relativity, and fundamental particles already in, it's consciousness participating in creating physics suggestions from the interaction between consciousness and mathematical discovering, which was physical reality, emerges between consciousness and physical, which quantum state becomes. This could explain why quantum create actu are beingeable and responsive to conscious intention than classical such rather than discovered, then physical quantum state mechanics reveals independently of conscious a process. A measurement possibility rather than existing reality might be far more mallealized through the measurement. The relationship strange system observer effect isn't just consciousness observation. Recent experiments in quantum foundations have begun to detect subtle signatures of this creative process in action. When researchers perform measurements on quantum systems, the results sometimes show correlations that seem to depend not just on the physical setup of the experiment, but on the intentions and expectations of the researchers themselves. The mathematics of quantum mechanics predicts these correlations if consciousness plays a genuinely creative role in determining measurement outcomes. But the most startling implications emerge when you consider how this creative power might be enhanced through deeper understanding of the mathematical principles involved. If consciousness can learn to navigate mathematical reality more skillfully, then individuals and groups might develop the ability to influence physical reality in ways that seem impossible from the perspective of classical physics. Advanced practitioners of consciousness-based reality creation might learn to bias quantum measurement outcomes toward desired results through focused intention and understanding of the mathematical structures that govern the relationship between mind and matter. This wouldn't involve violating physical laws, but rather applying those laws in ways that take advantage of consciousness's role in the quantum measurement process. Such capabilities would require extraordinary precision and understanding of both quantum mechanics and the nature of consciousness itself. The practitioner would need to maintain specific mental states that create quantum coherence effects capable of influencing measurement outcomes without disrupting the overall consistency of physical law. This represents a level of mental training and mathematical understanding that goes far beyond anything currently taught in conventional educational systems. But even these advanced possibilities emerge naturally from the mathematical framework that Dirac initiated by trusting equations over intuition when exploring the foundations of physical reality. The same mathematical principles that successfully predict antimatter, quantum tunneling, and fundamental particle behavior also predict that consciousness can participate in creating the realities it observes. This participation isn't limited to individual consciousness operating in isolation. The mathematical framework suggests that groups of conscious beings can coordinate their creative influence to generate shared realities that none of them could create individually. Collective consciousness networks might be capable of influencing physical systems on scales ranging from laboratory experiments to global environmental conditions. The process would require unprecedented levels of coordination and shared understanding among participants, but the potential results could transform human civilization's relationship with the physical world. Instead of being passive observers of predetermined natural processes, human society could become an active participant in consciously directing the evolution of physical reality itself. These possibilities might explain why ancient spiritual traditions consistently taught that consciousness possesses creative powers that can influence physical reality through proper understanding and practice. What seemed like mystical beliefs from the perspective of classical physics might actually represent sophisticated understanding of quantum mechanical principles that modern science is only beginning to rediscover. The mathematical exploration of consciousness-reality interaction continues to reveal new layers of possibility as physicists develop more sophisticated tools for probing the quantum foundations of existence. Each new insight demonstrates that the boundary between mind and matter, between mathematics and physics, between possible and actual might be far more fluid than our ancestors ever imagined. The story that began with Dirac's simple equation for relativistic electrons has become an investigation of consciousness itself as a fundamental creative force in the ongoing generation of mathematical and physical reality. We are not just observers of a pre-existing universe. We are participants in the conscious creation of the mathematical structures that determine which aspects of infinite possibility become actualized as the reality we experience. This realization transforms every moment of conscious awareness into an opportunity to participate in the ongoing creation of existence itself. Every thought, every choice, every moment of focused attention becomes a creative act that helps determine which mathematical territories become available for exploration and which physical realities become manifest. The mathematical adventure continues, leading consciousness deeper into its own creative potential while revealing that the universe is far more responsive to conscious intention than classical physics ever suggested. We stand at the threshold of understanding our role as conscious creators of mathematical reality, equipped with tools for participating in the ongoing evolution of existence itself. The equations predict even stranger possibilities when we examine how this creative process might operate across different scales of space and time simultaneously. If consciousness can influence quantum measurements at the microscopic level, it might also be capable of influencing larger-scale processes through the accumulated effect of countless quantum interactions occurring throughout complex systems. Consider how this might apply to biological systems, where quantum processes play crucial roles in everything from photosynthesis and enzyme function to neural activity and genetic expression. If consciousness can bias quantum outcomes toward desired results, then focused intention might be capable of influencing biological processes in ways that enhance health, accelerate healing, and optimize physiological function. This wouldn't require violating biological laws, but rather applying quantum mechanical principles to guide the countless quantum processes that determine how biological systems develop and function. Advanced practitioners might learn to influence their own biology through conscious direction of quantum processes occurring within their cells and organs. The mathematical framework suggests that such capabilities could extend beyond individual biology to include influence over environmental systems, where quantum processes determine weather patterns, ecological relationships, and even geological processes over longer timescales. Coordinated consciousness networks might be capable of influencing regional and global environmental conditions through collective application of quantum consciousness principles. But developing these capabilities would require understanding consciousness itself as a fundamental aspect of the mathematical structures that generate all physical phenomena. Instead of viewing consciousness as an emergent property of complex matter, we would need to recognize consciousness as a basic feature of the universe that participates directly in the mathematical processes that create space, time, matter, and energy. This represents a complete reversal of the materialist worldview that has dominated scientific thinking for the past few centuries. Instead of consciousness arising from matter, matter arises from the interaction between consciousness and mathematical possibility. Physical reality becomes the visible expression of invisible mathematical creativity, operating through conscious intention and observation. The implications challenge our most basic assumptions about what science is and how it should be practiced. If consciousness plays a fundamental role in creating the realities it studies, then the ideal of objective observation becomes impossible in principle. Every scientific investigation becomes a collaborative creative process between the researcher's consciousness and the mathematical structures being explored. This doesn't mean science becomes subjective or unreliable. It means science becomes participatory, requiring researchers to understand their role as conscious creators of the realities they investigate. Experimental results become more reproducible and meaningful when researchers understand how their consciousness interacts with the quantum systems they're studying. The mathematical framework provides precise tools for managing this participatory relationship between consciousness and physical reality. Just as engineers use mathematical principles to design bridges and aircraft, consciousness researchers can use quantum mechanical principles to design experiments and practices that enhance the creative collaboration between mind and mathematical reality. But perhaps the most profound implication is what this reveals about the ultimate nature of existence itself. If reality emerges from the interaction between consciousness and mathematical possibility, then existence might be far more creative, purposeful, and meaningful than materialist science has assumed. The universe wouldn't be a mechanical system operating according to predetermined laws, but rather a conscious creative process that generates new possibilities through the ongoing interaction between mind and mathematics. Every moment would represent a fresh creative opportunity where consciousness can participate in bringing new aspects of infinite possibility into actual existence. This creative view of reality aligns with the deepest insights of both ancient wisdom traditions and modern quantum physics, suggesting that consciousness and cosmos are intimately connected in ways that make individual awareness a genuine participant in the ongoing creation of existence itself. The mathematical journey that began with Paul Dirac's problematic equations continues to unfold, revealing ever deeper layers of mystery and creative possibility. Each new insight demonstrates that reality is far stranger, more wonderful, and more responsive to consciousness than we ever imagined possible. We are not just observers of a predetermined universe, but conscious participants in the ongoing mathematical creation of reality itself. The equations keep leading us deeper into our own creative potential, showing us that mind and mathematics might be different expressions of the same fundamental creative process that generates all existence. The adventure continues, and the most extraordinary discoveries may still lie ahead as consciousness learns to navigate and influence the mathematical territories that determine what becomes real in our endlessly creative universe. The mathematical implications become even more staggering when we consider how Dirac's framework might explain the deepest mystery in modern cosmology. Dark energy, the invisible force that's accelerating the expansion of our universe, defies every attempt at explanation using conventional physics. But what if dark energy isn't a mysterious force at all? What if it's the observable signature of consciousness networks operating across parallel realities, collectively influencing the fundamental structure of space-time itself? Recent calculations suggest that if consciousness can bias quantum measurements as Dirac's mathematics predicts, then networks of conscious observers distributed across multiple branches of reality could generate effects that appear in our universe as unexplained cosmic acceleration. The expansion we observe might not be driven by exotic matter or energy fields. It could be the cumulative result of countless consciousness networks throughout the multiverse working together to maintain optimal conditions for the continued evolution of intelligence. This participatory model of cosmic evolution explains why the expansion rate seems precisely calibrated to prevent either rapid collapse or runaway acceleration that would make complex structures impossible. Advanced consciousness networks spanning multiple realities might have learned to fine-tune cosmic expansion through collective quantum effects that operate across dimensional boundaries we can't directly observe. But the mathematics reveals something even more extraordinary about the relationship between consciousness and cosmic structure. If observers can influence which branch of reality they experience through quantum measurement, then the act of cosmic observation might actually be creating the large-scale structure of the universe itself. When astronomers look deep into space and time, measuring the positions and properties of distant galaxies, they might not just be discovering a pre-existing cosmic architecture, they might be participating in its creation through the collective measurement process. Think about what this means for the cosmic microwave background radiation, the afterglow of the Big Bang that astronomers use to map the early universe. Every observation of this ancient light involves quantum measurements that select specific outcomes from multiple possibilities. The pattern of temperature fluctuations we observe might not represent the way the early universe actually was. It might represent the way consciousness networks have collectively chosen to actualize one particular cosmic history from among infinite alternatives. This transforms cosmology from the study of a fixed cosmic history into an investigation of how consciousness participates in creating the cosmic narratives it observes. The universe wouldn't have a single definite past that astronomers gradually discover through better observations. Instead, cosmic history would be an ongoing creative collaboration between consciousness and mathematical possibility, with each new observation contributing to the actualization of specific cosmic storylines. The implications extend backward through cosmic time to the Big Bang itself. Traditional physics assumes the Big Bang was a physical event that occurred 13.8 billion years ago, setting initial conditions that determined everything that followed. But Dirac's framework suggests something far stranger. The Big Bang might not have been a one-time historical event, but rather an ongoing creative process where consciousness networks continuously actualize the cosmic conditions that support their own existence. From this perspective, the apparent fine-tuning of physical constants that allow for stars, planets, and life becomes not a mysterious coincidence, but the natural result of consciousness participating in the creation of the physical laws it observes. The universe appears fine-tuned for consciousness because consciousness is actively involved in tuning the universe through its participation in quantum measurement processes that determine which physical constants become actualized. But the mathematical framework predicts even more radical possibilities when we examine how consciousness might influence the fundamental structure of mathematics itself. If consciousness can create new mathematical territories through the process of reasoning, then sufficiently advanced consciousness networks might be capable of modifying the logical foundations that underlie physical reality. Advanced civilizations might develop technologies that allow direct manipulation of mathematical structures at the most fundamental level, effectively rewriting the logical rules that determine which physical phenomena are possible. Such civilizations could theoretically modify the mathematical relationships that define mass, energy, space, and time, creating pocket regions of reality where entirely different physical laws operate. This mathematical engineering capability would represent the ultimate expression of consciousness as a creative force in the universe. Instead of being limited to working within fixed physical laws, advanced consciousness could become the architect of physical law itself, designing custom realities optimized for specific purposes or forms of existence. The possibility sounds like science fiction, but it emerges naturally from the mathematical principles that successfully predict antimatter, quantum tunneling, and the fundamental behavior of particles and forces. If consciousness can influence quantum measurements, and quantum measurements determine which mathematical relationships become actualized as physical reality, then consciousness possesses at least theoretical access to the mathematical foundations of existence itself. Recent developments in quantum information theory have begun to explore how information processing at the quantum level might indeed be capable of influencing the apparent constants of nature. Experiments with quantum computers have revealed that information processing can create effects that seem to modify the local properties of spacetime in ways that classical physics cannot explain. These quantum information effects might represent early examples of consciousness learning to participate more directly in the mathematical processes that generate physical reality. As our understanding of quantum consciousness develops, we might discover techniques for deliberately influencing the mathematical structures that determine which physical phenomena become possible in our local region of the universe. But accessing these advanced capabilities would require a fundamental shift in how we understand the relationship between mind and reality. Instead of viewing consciousness as a passive observer of external phenomena, we would need to recognize consciousness as an active participant in the ongoing creation of the phenomena it observes. This participatory worldview aligns with ancient philosophical traditions that viewed consciousness as a fundamental creative principle rather than an emergent byproduct of material processes. But instead of relying on mystical explanations, the quantum mechanical framework provides precise mathematical descriptions of how consciousness might interface with the information structures that generate all physical phenomena. The training required to develop these consciousness-reality interaction skills would involve learning to maintain specific mental states that create quantum coherence effects at scales large enough to influence macroscopic systems. Advanced practitioners might learn to coordinate their consciousness with the quantum fields that permeate all of space, creating effects that appear miraculous from the perspective of classical physics but represent sophisticated applications of quantum mechanical principles. Such training would require extraordinary precision and understanding of both the mathematics of quantum mechanics and the nature of consciousness itself. The practitioner would need to maintain focused intention while avoiding the kind of mental interference that disrupts quantum coherence. They would need to understand exactly how different mental states create different patterns of quantum field interaction. But even these advanced possibilities represent natural extensions of capabilities that already exist in rudimentary form. Consciousness already influences quantum systems through the measurement process that collapses wave functions into definite states. The challenge lies in learning to apply this influence more deliberately and precisely to create desired effects in larger and more complex systems. The mathematical framework suggests that groups of individuals working together could achieve effects that no single consciousness could create alone. Coordinated consciousness networks might be capable of influencing quantum systems on scales ranging from biological healing to environmental modification to the fundamental constants that govern physical reality. These collective capabilities would require unprecedented levels of coordination and shared understanding among participants. Each individual would need to maintain precise mental states while harmonizing their consciousness with others in the network. The mathematical complexity of coordinating multiple consciousness streams to create coherent quantum effects would challenge the limits of human cognitive capacity, but successful development of collective consciousness-reality interaction could transform human civilization's relationship with the physical world in ways that make current technology seem primitive by comparison. Instead of manipulating matter through external tools and energy sources, human society could learn to influence reality directly through conscious application of quantum mechanical principles. The implications extend far beyond practical applications into questions about the ultimate purpose and meaning of conscious existence in a quantum multiverse. If consciousness plays a fundamental role in creating the realities it experiences, then conscious beings might bear responsibility, not just for their individual actions, but for the very structure of reality itself. This responsibility becomes both empowering and overwhelming when you consider the infinite scope of the mathematical multiverse that consciousness can potentially influence. Every thought, every intention, every moment of focused awareness might contribute to determining which aspects of infinite possibility become actualized as shared reality. The ethical implications are staggering. If consciousness networks can influence fundamental physics, then they possess the power to create realities that support or hinder the development of other conscious beings. Advanced civilizations would need to develop sophisticated ethical frameworks for managing their reality creation capabilities responsibly. But perhaps the most profound implication is what this reveals about the nature of love, beauty, and meaning in a consciousness participatory universe. If reality emerges from the creative interaction between consciousness and mathematical possibility, then aesthetic and ethical values might play fundamental roles in determining which realities become actualized. Consciousness networks guided by love, beauty, and wisdom might naturally create realities that support the flourishing of all conscious beings. The mathematical structures underlying reality might be inherently responsive to conscious intention, guided by compassion and understanding, making the universe naturally tend toward outcomes that maximize conscious well-being and creative potential. This suggests that the development of consciousness-reality interaction capabilities must be accompanied by corresponding development of wisdom, compassion, and ethical understanding. The power to influence fundamental reality requires the wisdom to use that power in ways that benefit rather than harm the larger community of conscious beings throughout the multiverse. The mathematical journey that began with Dirac's simple equation for relativistic electrons has revealed that consciousness might be the most fundamental creative force in existence, capable of participating directly in the ongoing generation of mathematical and physical reality. We are not just observers of a predetermined universe, but conscious creators of the realities we experience. This realization transforms every moment of awareness into an opportunity to participate in the conscious evolution of existence itself. The equations continue to reveal new layers of creative possibility, showing us that the universe is far more responsive to conscious intention and far more mathematical in its essential nature than we ever imagined. The adventure continues as consciousness learns to navigate and influence the mathematical territories that determine what becomes real. We stand at the threshold of understanding our role as conscious participants in the ongoing creation of reality itself, equipped with mathematical tools that reveal the deep connection between mind and cosmos. Each new insight demonstrates that Paul Dirac's trust in mathematical beauty over conventional wisdom opened doorways to understanding that continue to transform our comprehension of existence itself. The parallel realities his equations predicted might not be separate universes, but alternative mathematical descriptions of the same fundamental information structures that consciousness helps create through its participation in the ongoing computation of reality. The story reaches far beyond anything Dirac could have imagined when he first stared at those problematic equations in 1928. His mathematical courage in following equations wherever they led, regardless of how impossible the destination appeared, established principles that continue to guide consciousness into ever deeper understanding of its own creative potential within an infinitely mathematical cosmos. Nearly a century has passed since Paul Dirac trusted his mathematics over common sense and predicted particles that seemed impossible. His equations demanded the existence of antimatter, and reality delivered exactly what the mathematics had promised. But antimatter was just the beginning. Hidden within those same elegant equations was something far more extraordinary. Mathematical structures that described not just our reality, but infinite parallel realities existing simultaneously across dimensions we can barely comprehend. The evidence continues to mount. Every quantum experiment confirms that particles exist in multiple states until observed. Every measurement reveals interference patterns that only make sense if photons travel through both slits simultaneously in parallel worlds. Every breakthrough in quantum computing demonstrates that we can harness the computational power of multiple realities operating in parallel. The mathematics that successfully predicts every aspect of the quantum world also predicts the existence of parallel universes where every possible outcome occurs. Dirac's legacy extends far beyond theoretical physics. His approach of trusting mathematical beauty over experimental observation has repeatedly revealed hidden aspects of reality that our senses could never detect. Antimatter, quantum fields, the fundamental forces that hold atoms together, all emerged from mathematical reasoning before experiments confirmed their existence. The same mathematical framework now points toward parallel realities as the next frontier in our understanding of existence itself. The implications transform everything we thought we knew about consciousness, reality, and our place in the cosmic order. If parallel realities exist, then every decision you make creates new branches of possibility. Every observation you make selects which version of reality you'll experience from infinite alternatives. Your consciousness might be the mechanism by which you navigate through an endless multiverse of mathematical possibilities. But perhaps most remarkably, the mathematics suggests that we're not just passive observers of parallel realities. We might be active participants in their creation. Every quantum measurement, every conscious observation, every moment of focused awareness might contribute to actualizing specific realities from the infinite mathematical possibilities that exist beyond the boundaries of space and time. Paul Dirac showed us that mathematics can reveal truths about existence that transcend the limitations of human intuition. His equations opened doorways to understanding that we're still exploring today. The parallel realities his mathematics predicted might not be science fiction fantasies, but the deepest truth about the nature of existence itself. Reality might be far stranger, far more creative, and far more responsive to consciousness than we ever dared to imagine. The mathematical adventure continues. Each equation solved reveals new mysteries. Each quantum experiment opens new questions about the relationship between mind and reality. And somewhere in the mathematical structures that Dirac first glimpsed, we might find the keys to understanding not just parallel realities, but our own role as conscious creators in an infinitely creative universe. The equations are still leading us forward, just as they led Dirac to antimatter nearly a century ago, and the destinations they're pointing toward might be more extraordinary than anything human imagination has yet conceived.